Jmath.
Hi everyone, welcome to the grade 12 trig chapter, but we're starting off with the revision of grade 11 basic trigonometry. So please check the questions you would like to do, try them, and then only watch the memo with me and see what you can learn if you forgot something. So in this video, I'm not going to go into extreme detail with every topic. For that, I will load the grade 11 playlist for all trig that you need to know to be ready for your final exams. But for now, let's just practice these questions and treat it as a revision exercise for grade 11 trig. Question 1. If cos A is equal to that fraction, and A is an element of 90 to 360, calculate without the use of a calculator and with the aid of a diagram the value of 5 tan A cos A. Now that sentence structure is extremely important because if you read that, it identifies this type of sum. So I'm going to draw a sketch, I'm going to do Pythagoras, and then I'm going to answer their questions. So the first thing I'm going to do is I need to check, is the value they give me, is cos positive or negative? So I can clearly see no minuses. So therefore, cos is positive. And then I just check my cos diagram. So cos is positive in the fourth and in the first. And they will always give me another set of info that I can just double check where this triangle would be. So what they're telling me is this angle is not in quadrant 1. So it's either in 2, 3, or 4. And remember, I choose the quadrant that I have 2 ticks in. So in this case, my triangle is going to be in the fourth quadrant. And I'm just going to make it there. Okay, so I'm just drawing a 90-degree triangle there. And then what I have is, sorry, I forgot the A. So the A goes there. And then it is adjacent over hypotenuse. So adjacent over hypotenuse. And now I must show my teacher the Pythagoras step. So I can just say, okay, so opposite squared is equal to hypotenuse squared minus adjacent squared. Okay, and with that, I am going to do the square root of 25 minus 24. And the answer, remember, plus or minus 1. And then I look at the quadrant to see, is it positive or negative? So to establish if it's a plus or a minus, remember, it's going down from the x-axis. And if something moves down, it's a negative direction. And if it moves left, it's a negative direction. So therefore, it is a minus 1. Now I can actually answer their question. So they're asking me for 5 tan A cos A. So I can say it's 5 multiplied. I know I'm going to use a fraction, and I know I'm going to use a fraction. So tan, according to this triangle, opposite over adjacent, so minus 1 over 2 root 6. And then cos, like we saw at the start of this question, is just 2 root 6 over 5. And now, primary school fractions, if something is there at the top and the bottom, it just cancels out. And this answer is minus 1. Okay, let's go to the next one. Question 2. If tan theta is 12 over 5 and sine is negative, calculate the following without the use of a calculator. Once again, I'm going to start with the quadrant. So tan theta equals 12 over 5. That is positive. So tan is positive in 1 and 3. But they're also telling me sine is negative, and sine is negative in 3 and 4. So therefore, I know I'm working in the third quadrant. So I'm just going to draw my triangle there, always away from the cross, and then back to the x-axis. I can put theta there. Tan is opposite over adjacent, so the 12 goes there, the 5 goes there. Okay, now, big red lights are supposed to flash now because I moved left and I moved down, so both of them need to have a minus. Okay, so watch out for this one if you have a tan. They always like to trick you because there was a minus at the top and the bottom, and that's why you didn't see it. Okay, but trust your gut. If you go left and down, you know there must be a minus. Now I can just do Pythagoras to write in the hypotenuse. So hypotenuse squared is equal to minus 5 squared. Remember your brackets, extremely important. Plus minus 12 squared. That is going to be the square root of 25 plus 144, and that is 13. Now notice I'm not writing plus minus because the hypotenuse can never be negative. So there my triangle is complete. Now I can answer the questions. So cos theta is just equal to adjacent over hypotenuse, so minus 5 over 13. That's it. I get my marks for that. So remember, this question would be 2 or 3 marks because they compensate for you choosing the correct quadrant and for the Pythagoras. So even though it's just a quick answer, it counts 3 marks because they mark everything else you've done. Okay, question B. 1 minus sine squared theta. So for those of you who remember grade 11 very well, you would know this is just cos squared theta. If you forgot that, just sub in the fraction in there, and you'd still get to the same answer. So in this case, cos squared would just be adjacent over hypotenuse, but all squared. That answer, 25 over 169. Question C. Question C, sine theta over tan theta. So you can go with identities and change the tan to sine over cos. But you can also just do the fraction. So I'm just going to say sine divided by tan. And in this case, sine is opposite over hypotenuse divided by tan, which is opposite over adjacent, so minus 12 over 5. Then I'm going to tip and times. So I'm going to times, and then I'm going to tip, and then things cancel out, and the answer is just 5 over 13. So either way, you would still get to the same answer. How did this one go? Do you guys still remember this triangle type sums? Let's look at the next one. So now we're into reduction formulas. So this is part of every section of trig, so you must really make sure you know these. Please watch enough videos until this is second nature, but let's go. So for question A, what I like to do when I do these sums, and if I'm not confident yet, I just like to go and write what quadrants is this. So 180 minus is quadrant 2. 90 plus is quadrant 2. This one, I am going to add a 360, and then it becomes 180 minus theta, and that is actually quadrant 2 that I'm working with. That one is quadrant 1. That just helps me to see, is it going to be plus or minus? So now I can just go fill it in and get my marks. So cos in the second quadrant is just negative cos theta. Cos 90 minus, remember your cofunctions, so that changes to sine theta. It's first quadrant, so always positive. Then at the bottom, sine 90 plus is a cofunction. Sine is luckily positive in the second quadrant, but it changes to cos. But it stays positive, so don't get confused there. And then with the last one, I'm just going to add 360, and it becomes 180 minus theta. Second quadrant, sine is positive there, so it's just over sine theta. All of that cancels out, except the minus, so the answer is just minus 1. Okay, question B. So I'm just going to check quadrants again. I know this is quadrant 3, that's quadrant 4, that's quadrant 4, and then this one is actually quadrant 1. So remember, I can take away 360 as many times as I want, and if I take it away twice, I'm just left with tan theta. So very easy, just means quadrant 1. Okay, so cos in quadrant 3 is just minus cos theta. The tan in quadrant 4 is minus tan theta. Sine in quadrant 4 is minus sine theta, and then tan in the first, everything is positive, so just tan theta. Okay, the tans cancel out, okay, and I have 3 minuses in the sum, so I know my answer is going to be a minus. So I'm left with minus cos theta over sine theta, and okay, so we know that sine over cos is tan, but something you can actually also study is just cos over sine is 1 over tan theta. There we go, I'm done with that question. Okay, so these reduction formulas continues now, so let's look at question C. So with this one, I can still do the quadrants, but if you are comfortable, you really don't need to do the quadrants. Okay, so this one, quadrant 1, quadrant 2. Okay, now something very tricky. If a sine or a cos or a tan is squared, the answer they produce is always going to be positive. Okay, so it doesn't matter which quadrant it is. I know sine of a negative angle is quadrant 4, but it's squared, so the minus is going to cancel anyway. Okay, so I'm not even going to write anything there. Okay, so I can say cos 90 minus theta is a cofunction, so it just changes to sine. Then sine 180 minus, that is the sine quadrant, so it's just positive sine theta. Like I said, if anything is squared, it stays a positive, so the minus can literally just go away in the bracket. Okay, so I reduce this to a 1 minus sine squared, and this is your grade 11 identity saying this is cos squared theta. Okay, perfect. So normally with these, you can stop once you have one trig ratio, so a sine, cos, or a tan, then you stop. Question D. I'm going to go quadrants again, so this is quadrant 3, but it doesn't matter because it's squared. Okay, so it's going to be a plus. This next one is 180 plus 45. So that is quadrant 3. It is tan's quadrant. And then this last one is also squared, so it's going to remain a plus. So I can then change this into cos squared theta. Okay, it's supposed to be a minus, but it's squared, so the minus just goes away. Then that I can change into tan 45. Then the bottom is just going to be sine squared theta. Okay, so just ignore the x, that's a typo, it should be a theta. Now, I need to see what's going on there. So the top, I can put in tan 45. Remember your special angles? Tan 45 is just 1, so I can say it's cos squared theta minus 1. And at the bottom, I can actually change sine squared into 1 minus cos squared theta. Now, with one of them, I can do a sign change, grade 9. So I'm just going to do it at the top and say this is then 1 minus cos squared theta over 1 minus cos squared theta. They cancel out, and the answer is just minus 1. There we go. Those were the reduction sums. Can be tricky, but once you know your rules, it's actually quite easy. Question 4. If tan 22 equals p, write the following in terms of p. So please memorize this type of question. It's going to come up again in grade 12. All of these are, but this one especially in almost every paper because they make it quite tricky in grade 12. But for now, if I see this, I'm going to draw a triangle, and it's 99% of the times it's in quadrant 1. Okay, how do I know that? Because they tell me 22 degrees. So it's not more than 90, so it stays in quadrant 1. Now, to 22, I put there, and then tan is opposite over adjacent. So if tan 22 is equal to p over 1, my opposite is p and adjacent is 1. So therefore, I just need to do Pythagoras. Hypotenuse squared is equal to 1 squared plus p squared, and that is then just the square root of 1 plus p squared. Now, many people ask me, why does the 1's squared cancel but not the p? It didn't cancel. 1 squared is just 1. Okay, but the square root cannot cancel anything inside if it is more than one term. So please don't make that mistake. So this one is 1 plus p squared. Okay, let's look at all of these questions. So tan 202, I can immediately go and write as tan of 180 plus 22. So the goal with these questions is just to reduce everything to a 22 in some way, and then just see as my answer plus p minus p square root of p, what it would be. So in this case, this is third quadrant, and tan is positive there, so it's just a tan 22, and I know that is just p. That's it. I don't need to do anything else. The next one, tan 338, that seems like the fourth quadrant to me because it's between 270 and 360. So I'm just going to say it's 360 minus 22. That is the negative tan 22, and the answer is just minus p. Okay, question C. So that is another way of writing the fourth quadrant. So remember, I can just put in a 360 in front of anything with trig, and then it becomes clear it's the fourth quadrant. And this would just be minus tan 22. You can also study it as if there's a minus in a bracket, if it's a cos eats the minus, but sine and tan, the minus just goes to the front. Okay, so this answer is just minus p. Question D. Okay, so tan 518. That's way too big. So I'm going to subtract 360 from there. So I'm just going to write it up there, minus 360. Then I can actually see this becomes 158. And 158 is 180 minus 22. So once again, I need to take everything back to a 22. This is tan in the second quadrant, so minus tan 22. Answer is minus p. Okay, question E. Cos 158. I just did a 158, but it wasn't cos. So now if I use reductions, I can say this is the second quadrant, so it is minus cos 22. Now I have a 22. I can use my triangle. So cos is adjacent over hypotenuse. So the answer is 1 over square root of 1 plus p squared. And that's it. That's my answer. So for the first four, you didn't really need the triangle, but they will always put in one or two where you can't solve it without the triangle. Many people forget about the triangle, so I would always draw the triangle first thing when I see this question. Please don't lose your marks for not wanting to draw a triangle. Now, to get sine 22, luckily that's already in the correct format, so I don't need to do anything else. So I can just say, okay, so sine 22 is equal to opposite over hypotenuse, so p over square root of 1 plus p squared. That's it. That is all I need there. So, okay, guys, this was part one of the revision. In the next part, we're going to look at further reductions, identities, and general solutions. I hope this made sense. Go back to the grade 11 videos if you need more practice with this.
If this video helped you, please like and subscribe.
Jmath.